So let's continue. Just a bit of announcement. It seems we will have refreshments later, so that's good news. And after the introduction on Fedora QA, on Fedora testing by Amita Sharma, now we have Tim Flink speaking about Taskotron. So,
thank you. All right. What perfect timing for my computer to try going to sleep. All right, so as mentioned, I'm Tim, and I'm going to be talking about automation in Fedora with Taskotron. Just a little bit before I get started, the way that I generally give presentations is pretty informal. If you have a question, feel free to interrupt me. If you raise your hand, I don't see you, interrupt me. The whole idea is for me to be sharing knowledge with y'all. So if you have a question, odds are someone else does too, or someone else who may be watching the video later. So feel free to interrupt me at any time if you have questions, and I guess let's get this started. Amita talked about this a little bit before, but before getting into what is Taskotron, what are we doing for automation, I want to spend a bit of time talking about what Fedora QA is. And at least in my mind, Fedora QA is a group of people who are partially responsible for the quality of Fedora deliverables. So, if you find yourself doing stuff like, having multiple 4-hour meetings where all you do is, debate about how important a bug is, writing web apps, maintaining web apps to track those lists of bugs that you spend 4-hour meetings discussing, how important they are. Run 20 or more non-kickstarted installs of Fedora in a day. If you're interested in all these kind of things, that's the kind of stuff that we tend to do. I remember when we were looking to hire someone, he asked me, he's like, okay, so what's your job title? What do you do? And I thought about it for a second, and I said, well, there's the stuff that the HR system says. But in reality, it depends on the day of the week. And the job title for pretty much anyone on our team and anyone who's working on Fedora QA is doers of stuff that make Fedora better. So there's, being a lot of a volunteer organization, there's always more stuff to do than we have people or time to, get it all done. So one of the things that we want to do is start taking the sort of testing that can be scripted, that can be easily automated, and start doing more of that so we can free up the people who aren't just, human bash scripts to do the things that are much more difficult, if not impossible, to script and automate in that way. The first attempt that I'm aware of to do much automation in the Fedora space was a system called AutoQA. And AutoQA was, did a lot of package and update-based testing. So, it's kind of, well, we have a new build, let's run RPM lint against it. We have a new update in Bodhi, let's try to make sure that the dependency tree isn't completely broken. And that's what it was known for, and that's what it was really good at. We did have some attempts to expand on that. We had an attempt to start doing installer testing in Rawhide. There were a few other things that we tried to do, but it never really got into consistent production. There were issues, and it just didn't work well enough. As a specific example, right around the time when we decided to move on past AutoQA, we were asked to do some automation of static analysis on packages. Specifically, it was static analysis on compiled Python extensions to count the references and make sure that there were no memory leaks in the Python extensions due to not dereferencing those pointers during the execution. But it was one of those things that you'd think would be great for automation, but just because of various details, it wasn't something we could do sanely. So, we started looking at how do we, make our automation better. And when we, were deciding to move beyond AutoQA, it sort of begs this question. You have this system that's been running relatively well for 5 years. Why are you starting over? Why in your right mind would you go do this? And a lot of what drove it was the way that AutoQA was set up. From our perspective as developing it and maintaining it, it was really difficult. I was responsible for generally maintaining our production instance, and it would take me half a day to a day to set up my development environment. And you have to spend that half a day to a day to setting up your development environment so you can triage test results so that you could write something for that automation. That's crazy. And is one of the reasons why we, for some reason, we're having trouble finding contributors to help us. There were, other things, but basically it needed to change. When we were looking to replace AutoQA, we weren't, believe it or not, looking to reinvent the wheel. We didn't go, it's like, oh, this wasn't made by us. We have to make something absolutely new. The issue really was that, there aren't that many people who are doing operating system testing in the open source space. I can think of a few off the top of my head. SUSE, Debian, Ubuntu, and I'm not trying to slight any other groups by not mentioning them, but it's a limited space and they're all different. And nothing that we could find was open source and was going to work for us. And kind of keying off that the example I mentioned before about trying to automate some static analysis, what we need in Fedora is not just yet another system for running automated tests. We didn't need something that was doing the same thing we'd done in the past. We needed something that can run all of these tasks that benefit Fedora with the least amount of effort possible. Because if it's not easy, folks aren't going to do it. So Taskotron is something that I happened to start at PyCon US a couple of years ago. And it just, the idea came to me and I wrote a proof of concept in a couple of days. Unfortunately, with timing, being QA, had the proof of concept done, and then all of a sudden it's time, drop all of our development efforts and start testing Fedora 19 so we can get it out the door. So that delayed it, but the first use cases that we were targeting was RPM-lint, just because it's, whether you think it's useful or not, it is trivial from a development perspective, so it's something that's easy to start with. And the other one was the static analysis, which ironically hasn't actually been put into production yet, but it was an example of something that's different, so trying to cover multiple use cases as we get started. So keeping that emphasis on, we're working on a task, and it's been very clear from the start, or at least that's what we've been trying to do, is the name Taskotron is deliberate. We think of tasks as a superset, so it's not just tests, it's not just checks. It is stuff that is both in what you would find in a traditional test automation system, in addition to tasks that are outside the purview of what would traditionally be considered test automation. The idea being that if we were a traditional organization, if Fedora was, if this was something that was being developed by a company for sale, we'd probably have more DevOps people. So if we had the things like static analysis, if we had the things that may not be test automation, we probably have DevOps people that can set up CI, who can set up all those things to have it done. But Fedora is not really traditional. So why not add a little bit of effort to our test automation to give us something that just makes Fedora better? So the idea here, instead of reinventing the wheel, is to try and take the best parts of what people have already done. Try and make this very open source in spirit, not just in license. By taking all those best parts without having to deploy 20, 30 different systems. So one good example is hardware automation. I have no intention of getting anywhere near that. That's a really hard problem, and it's something that we really don't need to reinvent. So, when we want to do things that require hardware, let's delegate that to Beaker. Beaker is designed to work with hardware. There are smart people working on it. It does work, so why reinvent that wheel? why rewrite a bunch of different test suites? If we have something that we're packaging from upstream and they have their own test suite, why not try and have a wrapper around that, run their tests in our environment as integration tests, instead of pretending that we have 50 people who do nothing but write tests and we can rewrite all of these things in whatever runner, whatever language we want. So the idea is not for us as automation developers to pretend that we're experts. If I got up here and said, I'm an expert on everything that's in Fedora, I'm an expert on testing X, I'm an expert on Wayland, I'm an expert on all of these things, I would, if you guys didn't laugh me off the stage, I would be able to prove that you weren't listening to me. So instead of pretending that this is true, try and make it as easy for the domain experts to contribute tests and to help us with these things as possible. So we're just enabling them and getting out of their way. So then we get to what I define as Taskotron. I think of Taskotron as a framework upon which automated tasks can be run, which is wonderfully vague. I added the thing on there to make Fedora better, but hopefully that's not necessary. But this is really not limited to stuff like RPMlint. Someone actually said that to me. It's like, well, why aren't you using Taskotron? Well, what I'm doing is more complicated than RPMlint, so it wouldn't work with Taskotron. I do very much, and if you'll hear me say this, maybe not more today, but you'll probably hear me say it in the future. The idea of Taskotron is that if you have something that runs on a type of input that we support, build notifications, update notifications, something that's common in Fedora, even if we don't already support it, you can probably run it on Taskotron. If you can have your task return results in a standard format, the things along the lines of tap, things along the lines of XUnit, we can probably report that, and then you can focus on your task, and you don't have to write your own scheduler. You don't have to go to infra to ask for your own resources. You don't have to go do all of this. Let us do a lot of that hard work, so you can be the domain experts, and we can all make Fedora better. So some of the big things that changed with Taskotron, just not necessarily the details of how it works, but from a user perspective, is another thing that you will hear me say again, because this is something that I don't think has come across very well yet. Taskotron does not require the entire system to be installed in order to develop tasks for it. The whole thing, and this is one of the big design keys when we started, the only thing you should need is the runner. If you find yourself in a situation, you're writing a task and you think you need the entire system, you need the results reporting, you need the trigger, you need the task the job execution engine, come find me, because there's a bug somewhere. We either have missing documentation, we have incorrect documentation, or there's a bug in our code and I want that fixed. It's something that drove me nuts about AutoQA, and I'm not willing to have that happen in Taskotron. From our perspective, as far as deployment and development, it's much more modular. I think we've hit a good balance on being about as flexible as we can be without getting down to the path of insanity and uselessness. So it's much easier to develop. It's much easier to develop for. The code is better. We have better practices. It's all around, hasn't changed a whole lot from the front end. But when we got started with this, the idea was we're taking one step back and sort of a step to the side so we can start moving forward and deliver on things to, again, make Fedora better. Oops, wrong button. So, I've talked a lot about these lofty ideals, about what was wrong with the old system, what's great about the new system, but let's get into a little bit more about how it actually works. So the idea of Taskotron is we have formulas that are written in YAML. I'll go through one in the demo at the end on what's exactly in there, but there's some stuff about description on what it is, who's maintaining it, what the environment needs to look like for the task to execute, and then go through the steps of, all right, execute this, report this, Stuff that's relatively straightforward. One of the things that we decided from the beginning is we're going to use Git repositories so that the task formulas and any of the supporting files needed for the task are stored in the Git repository. If someone is maintaining a task, the idea is, okay, I need to change my task. I'm going to make my change. I'm going to do a Git commit. I'm going to push it, and then I don't have to worry about it. The next time that task is executed, those updates will be pulled from the repository, and you don't have to worry about building packages. You don't have to worry about updating metadata. You don't have to worry about any extra steps. You just have to treat it as if it were code, and you needed to update it. Taskotron's scheduling is all about Fed messages. At this point, pretty much everything in Fedora has a Fed message associated with it. New builds, new updates, compose starts, compose completes, just about everything. So the way that our scheduling works is we listen for Fed messages, and based on those Fed messages, we will run a set of jobs. And by default, those go into our results storage engine. Results database engine, whatever term you choose to use. And it's relatively basic, but that's something that can be expanded if it is you turn out to need more. So now let's get into some pretty pictures. So this is a graphical, sort of very high level representation. I mentioned before how it's supposed to be modular. So a lot of this is very vague. I don't talk about the fact that this is really build-bot for the most part. So the whole life cycle of, or the cycle of tasks is we have Fed messages. So something comes in. So say there's a new build of Python Flask. Flask is a web framework written in Python. So that comes in, and we have our rule engine, and then it says, oh, I saw this. Okay, so we have a new build, and it's for Python Flask. All right, so looking through my rules, I need to be running RPM-lint on that. And oh, look, there's some task-specific, or there's some package-specific tasks that I need to run. So here's the ones that I'm interested in. And all of these arrows right here, this is all RESTful interfaces. They speak in JSON with messages in JSON. So we have our rule engine. We've identified the stuff that needs to be scheduled, and it notifies the task execution engine. It says, OK, so here's my input. I have Python Flask, and I want to run these tasks. Go. And then the task execution engine goes and runs with that, and it allocates resources, and it gets things set up, does the task, and starts the reporting process, which then goes over JSON, over RESTful JSON to results storage. And as this is cleaning up after the task execution, stores it in a database and emits appropriate Fed messages. So our task cycle is complete. It's kind of like the cycle of life. It's just less Disney. So we can have then more complicated dependencies. So if you have a task that produces output that another task needs, since triggering is on Fed messages, and at the end of completion you have Fed messages, you can start having dependency chains. So now I've talked about all of these things that, to be honest, is what we are shooting for in a 1.0. We're not quite there yet, but we are shooting to be there hopefully at the end of this year. But what do we have right now that's in production? Our first step was to replace AutoQA. There are only so many of us that are developers, so the last thing we wanted to have was multiple systems in production that we had to maintain, both from a human resource point of view and a hardware resource point of view. Not going to happen. So our first step was to revamp our development processes, retire the old system, but make sure that we didn't lose any functionality. That's complete. That's been running in production, and that's been from my opinion and from what I've heard, has been running well in production for a couple of months. And now it's time to start moving past that. So what exactly are we currently working on? We've talked about what used to be with AutoQA, what we want to do with Taskotron, what we currently have with Taskotron. Where we're going right now, the two major deliverables we're working on is better accounting of execution. Right now with Taskotron, if you're an administrator, you can probably piece together what Fed message caused what job to execute when and what the results were and be able to hook all of that together. But what we want to have is to make that public and a lot easier so you're not logging into 3 systems trying to piece stuff together. So you can go from, all right, at this time I had a Fed message which hit this rule and this job were scheduled, and this is what happened when they were executed, and here are my results. To have that in a public-facing web page so that any user can go find that information, and it's not just the administrators trying to piece things together. The other big thing that we're working on right now is disposable clients. And when I say disposable clients, this is basically making sure that test environments are clean at the beginning of a task. Right now, we just keep reusing the same execution environments. So, stuff like, say, someone wanted to install 50 packages. After a while, that's going to fill up our clients, and it's going to cause problems. If someone wanted to try a destructive test, like try to, RMRF root, that's also going to cause problems. But what we want to have is, to treat these clients like they're disposable, so that's a consistent place to start from, and it doesn't matter what happens during the execution of that task, because once we collect data and then we start over, it's always going to be clean. And that in itself isn't so big of a deal. It's what that starts enabling us to do. The sort of things that we've been promising for longer than I would like to admit. One of those is what I've been calling a dist-git style package tasks. So the idea with Fedora is we have one Git repository per package. What we want to have is something similar for tasks. So you either have packagers or you have testers who are interested in that package be able to submit things so that all they have to do is commit to some form of a Git repository. And every time the Git changes for that package or there's a build, you have a task that's automatically executed. So we can start having more automated integration tests. So we can start having these things to find problems earlier, to go with my theme that I keep saying, to keep making Fedora better. The other thing that it will enable us to do is user-submitted tasks. Right now, because the clients are being reused every time, we keep a pretty careful watch on what's executed. If the environments are rebuilt every time, that's less important. It's much easier for other people to contribute, and we can have more tasks run on Fedora. So it is demo time. And while I've been accused of being crazy before, I am not crazy enough to run proof of concept code as a live demo with limited network access. So this is going to be pre-recorded. If you want to see it live, you can find me later, but I'm not going to do that live with questionable network access. Well, I'm sorry to disappoint you. You'll have to watch me fumble around, I guess, explaining. I'll try and screw up somewhere else if it would make you happy. All right. So what this demo is going to be, this is proof of concept code using the disposable client stuff we're starting to work on. This particular check, the idea is to get a cloud image, run some very basic sanity checks on it, and see if they work. So is this big enough for people to read? Yeah. OK. So just going through the anatomy of this, the task formula. So we have basic stuff, a name, a description, and the maintainer. And this is as much for humans to go figure out what's going on, who's responsible, what's going on in anything. An input section. So this is ignoring the fact that we don't actually, to the best of my knowledge, have 32-bit cloud images. So the arch doesn't really matter, but this is a proof of concept, and I'm just kind of keeping things there. So this is, saying that it requires to be it needs to be passed an arch. It needs to know what arch the input is. So then we start describing the environment. The specification still needs work, but the idea here is that for a cloud test, we have one virtual machine that is actually going to run the task. So that's responsible for, poking at the cloud image to see, can I install packages? Does that, package start up? And that's what our first one is. So we're using the Fedora 21 cloud image, and we have a small size on it. But for this particular thing, it's really...
Sorry. Since you're doing this, this is something you run every day, right? This is something you run regularly.
Yeah.
To specify, that's a very specific cloud image. Is there not a way to say, test the latest successful cloud image or something instead of...
There will be. This is code that I'm unwilling to put in our canonical repository. This is in my own fork. So right now there's not, but yes, there will be. The idea is to run this every time there's a compose. So there's a compose, we get a message saying, hey, there's new cloud images. So then this would find those new cloud images and run the task on them.
So this is the image being tested or the image where the tests will be run?
Which? There are two things here. I've called them, I wish this had better syntax highlighting. So there are two virtual machines being described here. I've chosen to name them machine and client. The machine is what is going to be executing the task. The client is a description of the virtual machine we are going to boot that has the cloud image under test in it. Does that answer your question? Any other questions? Cool.
You lost me here. Can you explain that again?
And I will explain it again, but I do want to reemphasize this is not what it will look like when we are done. This is early proof of concept code. So the difference between them, so the idea is we have, let's see if I can do this big enough for it to be actually read. So the whole idea behind disposable clients is that we start using virtual machines to have a clean environment. So instead of trying to run them, in this environment we keep reusing, we have a task VM that's created. So this would be, even if we weren't doing cloud images, say we wanted to do,
We need something clean.
yeah, so we need something clean. So we have this task VM, and this has libtaskotron in it, and this is responsible. So we push then our formula file to this, and it does actually executes it. In the case of a cloud image, it doesn't make a whole lot of sense to try and do this in the image under test because you don't know if it's going to work. This is, in my mind at least, this is better to have some known good. So if we want to have our cloud image, we spawn a second virtual machine. So then this task then starts poking the cloud image and then gets the results.
Okay.
So does this process make sense to everyone, what I'm trying to describe as far as what's going on?
Yeah, now it does.
Okay, so that's, it's the description I admit is a bit awkward, but that's what we're trying to do. So this machine with, the specific image and the...
Task controller or something, the machine controlling the task and stuff.
Yeah, so it needs work.
If you were testing something else than a whole image, if you were just doing an RPM link check, for example, you still have that second
No.
image defined?
Nope.
Okay.
This is something that it's only if you need that second virtual machine. The one that you would almost always have is this one. This one is specific to, in this particular case, trying to do the cloud image because we need the second virtual machine to actually test it.
Yeah, I thought you were using nested virtualization.
We could,
But yeah.
not at the moment.
So it is for a post
Yes. So it is, I gotta hurry up. It is, so basically the cloud, we would get a Fed message that says, okay, the compose is complete. And as part of that compose, there is a cloud image. And that cloud image would be, instead of being statically defined like this would be passed in as a variable. So this would be derived from the Fed message, and this would be the new image that we're trying to test. Any other questions? I hope not, so I can finish. Okay, so going on from there, so we have our very oddly described virtual machines that we're executing stuff in and on. And we have RPMs that need to be installed inside of our task controller for this particular thing. In this particular case, we're interested in PyTest, Paramiko, and requests. This is all the environment that things are going to be executed in. But we need to describe what needs to be done. In this case, I have a Python file that needs to be run, and I have a callable. In this particular case, it's a function. And it needs to be passed the IP address of this virtual machine when it's created. We export it, it gets reported. I will quickly show you this. This is horrid code, so pretend I didn't write this. I'll blame it on someone else. The basic thing is what it does is it installs Nginx, it starts it, and it does a simple test over HTTP. Basically, it puts a file on the remote machine in a place that's accessible over HTTP, and then basically does a wget to get that file back, and it's a simple test of, hey, the service is set up with its defaults, and it's working. So where is... all right, so playing back at 2 times speed, so you can have an idea of more than 2 times speed. So we're going through, and we have our version of our runner that's being talked about. And there's a bunch of different setup. This stuff in here is we are booting the first virtual machine. So the first one that gets booted is the one that's actually going to be executing the task. But in this case, we need a second one, so you can see very similar output repeating itself. And once the second virtual machine is booted, now we start the actual task execution. So where'd it go? Okay, so we add our SSH keys. It's moving too fast. Maybe I should have slowed it down. So we install the runner on this so that we can actually start executing the tasks. Doing other stuff, doing other preparation, and eventually we start running the command on the remote host. And that command is the poorly written Python file I showed you. And when we're done, we end up with results that look like this. So we install Nginx, that passed. We started Nginx, that passed. We did our simple test of putting a file and getting it to make sure that the HTTP works. So in this particular case, everything passed. And that is a recorded demonstration. It would have taken, on this laptop, it would have taken quite a bit longer. Did this process make sense? I went through it pretty quick, but did it? Okay. Any other questions? Yes. Yes, that's what we've sort of defaulted to. Keeping with the idea of, if I go back to my pretty picture, here, one of the things I had said that we want to do is make sure that the boundaries between these are RESTful services and JSON. Keeping with that in spirit, what we want to have those standard interfaces, I guess I'll call it, between what the tasks are going to return. So either tap or we're going to end up supporting XUnit at some point. So if the things, it's sort of like Central CI, and I know there's other things Jenkins, I think, has a similar concept. If your stuff returns XUnit, Jenkins can understand the output. So it's a similar idea. We've just sort of defaulted to tap.
I was interested in knowing the rationale for tap over XUnit.
He was asking about the rationale of tap over XUnit. The rationale was that tap is more flexible. Since we're trying to do more than just the traditional test automation, XUnit is very much, it came out of JUnit, so it is pass, fail, pass, fail, pass, fail, which is an important bit, but some of the stuff you can do, see if I can show it off. One of the things you can do with newer versions of tap, specifically starting with tap 13, is you can embed YAML in it. And in my mind, it's a bit more flexible, and it doesn't have nearly so many eye pokey braces. So it's...
You mean it's more human readable, even though it's a machine readable protocol?
That's a more elegant way of putting it. The way he said is it's a more human readable version of a machine protocol, which is a more elegant way than my eye pokey braces comment. Any other questions?
So just one more. You mentioned about having, dist-git for all the tests. I was wondering if you were, where is the rules engine? Like if you're, say, having Apache tests, are the rules also in dist-git, or is there two different places you have to, go to?
The question was about the rules engine and how we were going to handle that with dist-git, specifically where the rules are and how people would update that. That is something we're working on to be honest, we're working on the disposable clients first. That hasn't been formally spec'd out yet. The way that I want it to work, or the way that I think it's going to work, is for stuff like dist-git, that's going to be a relatively default thing, where we go through and if someone has the rule or the tasks in package specific Git, we just go through and say, oh, I just got a build message for this package. Is there anything in the Git that corresponds with that package? If there is, execute it. If there isn't, ignore it. So it's sort of a try and rely. The idea is to rely on defaults, so that all the task maintainer would have to do is just put the files in the right place, and our rules engine is smart enough to go say, well, here's where they would be if they existed. And if they exist, use them. If they don't exist, ignore them.
I was just wondering if it would be flexible enough to allow the test writer to use the harness-state flags, like be able to use AutoA maybe, or if they're kernel related, maybe use Beaker for that type of.
Yes, it is, but it would. The way I see it working is a little bit different. So that instead of being in the rules engine, you would have something. Like this is what we call a directive. So this is basically something that calls a Python file. So we would have a Beaker directive, or we would have various directives. Worst case scenario, we have a shell directive, and so they write a bash script that kicks off their framework of choice. So the flexibility ends up being in the formula, not necessarily in the rules engine.
This could be in this.
Yeah. This is the thing that would be in dist-git that would describe what needs to happen. So the rules engine just looks for this YAML file, or it looks for this formula, and then from there things could be delegated to Beaker, things could be delegated to whatever harness people are looking to use. That answer your question?
So for somebody who's new to Fedora QA, can you give some examples like how set of rules or tasks that you plan to include further in Taskotron for it to be?
The complete question was, for someone who's new to Fedora QA, can I give an example of the rules and tasks that we're planning to include?
Yeah. So that somebody can contribute, like how can somebody start to contribute?
I'm trying to think of.
Or
Wow, I
maybe
don't have a good answer to that. Did any of you guys? Right now, yes, but it is not incredibly easy at the moment. We still have a couple of things to get done in order for it to be as easy, because some of the stuff, and I hope I was clear on what we will have by the end of the year and what we have right now. Right now, I don't have a simple answer. If you're interested, come find me, come find Camille, come find one of us, and we will help you get started. But I don't have a quick, easy answer for that right now.
You mentioned that the tab results formatting engine is more flexible than the XUnit one. Would it work with something like where you have kind of a fuzzy success result, like not just pass fail, but like I found something, please look at it, or I didn't find something, or some part of the test failed, like something like that? Would that work?
The question, and I'm out of time, so this is going to be, I saw another hand come up, but I can talk to you afterwards. The question was whether or not we could have something more fuzzy for pass-fail. And my answer for that is I think that we need to have discrete things, that there needs to be discrete meaning. So, I mean, yes, we actually have more support than just pass-fail. And I'm probably going to miss one, but it's like it's pass-fail, needs inspection, crashed. There's a few things like that that can be returned. So it's not just a binary passed-fail, but there are a discrete number of states that need to be returned. So one of a discrete number of states. All right, well, I'm out of time. So thank you very much for listening, and thank you. Ah.